In this section, we're going to be looking at frequency distributions. Now, frequency distributions show how data are partitioned across several categories or classes by listing these categories along with the number or the frequency of the data values for each one of them. Let's take a look at a quick example. Here we see data from an ongoing study in Flint, Michigan, in this case focusing on pathogen levels in the water. Looking at this data, we can see that the pathogen associated with Legionnaire's disease is occurring in a higher level than in the Flint homes and in the Detroit water businesses or in the Flint businesses. So this is an important area to pay attention to. Looking across this frequency distribution, we can already see some of the areas we'd want to focus on if we were doing a study here, and some areas that might not be as meaningful. This is a really important part when you're looking at really large data sets and you're under a time constraint. Sometimes you need to decide where you're going to focus your attention and what you're going to come back to later. And frequency distributions help you make these first assessments based on data. So let's move on and take a look at how to create a frequency distribution. We're going to be working with, again, our sample data here, looking at dog heights. And we find frequency distributions are made up of several components: class width, lower class limits, upper class limits, class boundaries, and class midpoints. And your homework problems in your exam are going to ask you to identify these for various frequency distributions. So we're going to go through each of these terms and look at how they relate to this particular sample set. So the first step in producing a frequency distribution is to decide on the number of classes you will set for your data. This varies between 5 and 20. In most cases, we'll be using 5 classes for our frequency distributions, but do keep in mind again, the class sizes has to vary between 5 and 20. It cannot be 4, it cannot be 32. The next step is we need to calculate the width for our classes. To get this, we're going to take the maximum data value that occurs in the data set and subtract the minimum data value from that, and then divide it by our number of classes. Thus, the class width is unique for each frequency distribution and must be calculated. In this particular example, we have 858 minus 170 divided by 5. This gives us a class width of 137.6, which we round up to a convenient number of 138. Pay careful attention here that we always round up to the convenient number. So this is very different than your regular rounding rule. If this had been 137.2, we would have still rounded up to 138. Be very careful here. This is a place where people easily make mistakes, and as you can imagine, if you make this mistake in the first part of your exam, you're going to miss a lot of points because all of the rest of your calculations are going to be off. So make careful putting this in your notes and identifying it, circle it and write it in red if you need to, so you don't skip this step. So our class width is the difference between 2 consecutive lower class limits or 2 consecutive upper class limits. Notice this is not the same thing as the difference between an upper and a lower limit of a single class. We'll come back to this at the end of this example so you can get a visual of the difference between these two. Alright, so now we're going to choose the value for our first lower class limit. You can use the minimum value that occurs in your data set, or if you want to, you can choose a convenient value below that minimum. In general, go ahead and use the lowest limit of minimum value that you've got in your data set. So here we're setting 170 as the first lower class limit. Now, in order to get the class limit for the second class, we're going to take the class width for the first lower class limit and we're going to add it to our class width. So here we're going to have 170, which is the lower class limit, plus 138, which we just calculated as our class width. And that gives us 308 as our second lower class limit. We're going to go home and repeat this for all the classes. And then we're going to put this into the frequency distribution, the chart that we're in the process of constructing. So here we can see on the right hand side the lower class limits listed in the vertical column, and they are the smallest numbers that can belong to each of the different classes. Now next up, we're going to look at calculating our upper limit for each of these classes. To do that, we're going to take the lower limit of class 2 and subtract 1 from it to get the upper class limit for class 1. So the upper class limits are the largest numbers that can belong to the different classes. You can see again, I've gone through and done this for each of our 5 classes. So now we have our lower class limits and our upper class limits. The next step is to go through and for each individual data value mark and put a tally mark in the appropriate class with the column labeled counting, which I strongly encourage you to include. Don't skip it. It seems silly for this small data set, but when you start working with larger data sets, it's going to be easy to make a mistake if you try to keep track of this in your head. Then you're going to add up your tally marks to find the total frequency for each class. Alright, now another terminology we need to look at is class midpoint. This is the value in the middle of each class. So each class is going to have its own lower limit, its own upper limit, and its own class midpoint. So to calculate the class midpoint for class 1, we're going to take the upper limit, 307, subtract the lower limit of 170, and divide this by 2 to get the point in the middle, the halfway between these. Then we take that point, 68.5, we add it back to the lower limit of 170 to get the midpoint value for this particular class of 238.5. If we go through and follow the same process, we can see the midpoint for class 2 is 376.5. So, the last terminology we want to look at here is our class boundaries. Now, class boundaries are numbers used to separate classes without the gaps created by class limits. So if you look at this example I have here, in the green we see the class limits. So for class 1, we have a limit of 170 to 307. However, the class boundaries are the spaces between, the middle of the spaces between each of these classes. So the class boundary would be 169.5 and 307.5. Make sure you get this in your notes, and again I suggest you copy this diagram in so that you don't forget it. This is another place where you can make a really easy mistake on your homeworks and your exams that will cost you points. Okay, so here's our completed frequency distribution. Don't forget you need to include the level of measurement for any type of continuous data. Alright, now let's do another practice problem with a little bit more data. Here we have the class pulse rate data from a previous class. So you're going to go through and construct a frequency distribution for this data, and then you need to identify each of the following components of this data set. Now, I've got a helpful tip for you to keep you from making easy mistakes. One of the common occurring problems in working with data is that individuals do not accurately enter all of their data into their frequency distribution. This is a really common mistake and easy to make. So let's look at what you need to do to keep from making this error. First, list out all of your data. Print out a sheet, copy it down very meticulous to make sure that you've got it exactly the way it is before you start to work with it. Next, you need to go through and put your data in order. You can go from lowest to largest, just as I have here, or largest to lowest. It doesn't really matter, but they need to be put in order. As you go through and write each piece of data here into your order, you need to mark it off on your raw data chart. This is really important so you can make sure that you're not double counting a data point or leaving one of them out. If you find that you've skipped a data point, such as I did here with number 63 in red, go through and at this point you can add it in just as I did so that you have it correct in your chart. This way, it helps keep you correcting your mistakes. The important thing is that when you're done, you've got your data listed out correctly. Also notice that if you have a data point that occurs twice, such as the 66 underlined here in green, you need to write it down twice. So, in your own notes, go through and complete this for this class pulse rate data. Complete going through and producing your data in order, then go through the steps and build your frequency distribution. Pause the video here, go through those steps and get that in order, and then when you've completed that, move on to the next slide and let's check our work together, just as we would be doing in class. Alright, so here we have the completed class pulse rate frequency distribution chart that you should have. You can see here that when I went through and did my counting, just as when I had gone my class pulse rate data, I marked through each of the items in my chronological order of my data values, again, to make sure that I'm not skipping any data or double counting it. This may seem like this is a waste of time or overly fussy, but remember, statistics rewards you for getting it right, not going quickly. If you get this wrong, this can throw off all of your answers for your homeworks and your exams. So take your time, make sure you've got everything correct before you move to the next problem. So here, when we're finishing this up, here is our frequency distribution over here on the left from the board. And here we can see we've pulled out and identified all of our pieces of information. So the class width, again, 76 minus 60 gives us 16. We divide that by 5 because we've got 5 classes. That gives us 3.2, which, remember, we round up to 4. Remember the rounding up. This would totally have thrown you off if you made this mistake. Also notice, by the way, that when you're doing your frequency distribution chart, you need to remember to include the level of measurement that you used. Going back through and looking at the rest of this, we can see our lower class limits here would be 60, 64, 68, 72, and 76. This is exactly the way that you would be entering this information in your homeworks and the exam questions. So I've tried to mimic that as much as I can here in this example. Again, we see our upper class limits. Then we have our class boundaries. Remember, the class boundaries are different than the limits. If you need to, draw out that diagram for yourself again real quickly to keep you from making mistakes. And then we have our class midpoints. All right, the next video that we'll be looking at is when frequency distributions are not quite enough. Where do we go from there?